Right, so what we're going to do today is, well, in summary, we're going to talk about where's weather going and what causes extremes. And this is similar to a number of presentations I've given in different places, but especially similar to the one I gave in Albuquerque to the Electric Universe Conference March last year. So we're going to first of all do a little bit of kind of now, just look at the weather as it is, or some important things quite recently, then dismiss the nonsense of man-made climate change, and then have a look at more interesting actual physics. Okay, and I think it will relate to what you just heard. Well, I'm sure it will, and I think this is definitely the best order we've had them in, because there's new stuff that you've heard before, some of which is definitely an extension of what I've heard from those quarters before. And I'm fully in favour of the electric universe concept of, you know, the cosmos and the sun and the weather connections. All right, so let's go then. Okay, so why is it important? Well, obviously for the economy and so forth, the weather does have a huge impact. For most members of the public, they treat it more as entertainment, actually. Although, you know, hidden behind that, there is big economic importance in crops and communications and transport. And in the case of farming, insurance and energy and commodities markets, it is very important to know the weather. Indeed, we have people involved in energy trading who have made quite a bit of money out of our forecast in Scandinavia, which is the most variable energy market in the world. Now, this was a quite important period, which is why I've got it here. End of January, start of February this year, where we forecast a whole number of things, but they were related to our finding that, well, it's been known since the 60s that when there was sudden warmings of the upper stratosphere, they were followed by an increased waviness of the jet stream. Okay, so when you had these sudden warmings of the upper atmosphere, the jet stream would, this is the jet stream you see of upper air moving round and round, in a kind of air current, if you like, but the number of waves in a circle would increase. Okay, so the K number, I think they called it, something like that. But okay, and we have a method of predicting these, and furthermore say that it's not the first ones in the upper atmosphere which count, but they precede then warmings in the lower atmosphere. And if you work out the amount of energies involved, there's a lot more energy in the warming of the lower atmosphere than the upper atmosphere. So we have these actual stratospheric warmings happened. There's the ones in the upper atmosphere, ones in the lower atmosphere, a little series of them. They did happen, and on cue, and we also said they will result in, for example, big blasts of cold air here, because the jet stream was going to be forced south, and you can see all this cold air there. And in the British Isles, there was a similar thing. I mean, it's going to be warm somewhere else as well, generally, but we identified that with this quite explicit, a displaced polar vortex would take place in the British Isles, you see. So we're very pleased with that prediction, although it's based largely on observed correlations mixed with ideas and then predicting these things. So that's an example of electric, well, it must be related to things happening in the upper atmosphere, in the electric currents. Now, it'd be good to know when I've got these periods, which we call these R periods, we can predict when we're going to have a lot of impact from the sun, and this will cause tighter isobars, greater precipitation, more tornadoes, more thunderstorms, and so forth. And these are called R5 is the strongest, R4 is the next one down, R3 and so on. And those, I'm 90% sure, would coincide with certain developments of currents in the ionosphere, etc. But we haven't done much work on those connections, and really we should do more work, you see, with the previous speaker on that. Okay. The point was that the Met Office had been floundering for some time about this period, and we had said, 100 days ahead in this time window, early December, there's going to be a cold plunge, you see, over Britain and northwest Europe, and it did come on cue. Now, some of these things don't come on cue, of course, but generally speaking, when we've got our R periods, that is red warning periods, the success rate is very high, like 90%. So, now, back to the CO2 nonsense, just to get it out of the way. The assumptions of standard meteorology are that weather drives weather. Okay, what happened yesterday? Put into a computer, make a map of what therefore must have been on the ground or in the upper atmosphere or the middle atmosphere in order to make the weather that happened, and then project it forward in time using Newtonian physics, standard thermodynamics and so forth. And lots of computing power to solve differential equations. But you see, that approach does not produce signals. Real weather data contains signals. There's a 22-year signal, there's a 60-year signal, there's a 155-day, which is the same as the frequency of solar flares. There are loads of signals. Standard meteorology doesn't advance any signals, or if they do, they say they're somehow internal to the atmosphere, and they struggle a lot to try and produce the quasi-biennial oscillation, for example, of 2 1/3 years. But they don't really. Well, they claim to produce it, but of course they're not able to predict anything. So they haven't really produced it. And of course, the other things that happen, which follow from an electric universe view of things, is ice ages and so forth. Now, I don't know, we could do an instant quiz. You probably all know the answer. What is the percentage of CO2 in the atmosphere?
0.04.
Yeah, that's all right. Very good. Percent. Yeah, okay. Well, I know you probably all know. Interestingly, when I did this Shropshire farmers, they, varied from 10% to, you know what I mean, completely mad figures. But the point is, the public just don't know. They do not know. They think that CO2 is a bad thing and there's a lot of it around. Well, actually, it's a good thing and there's hardly any of it around. Okay. Right. What we have is equivalent to 1 1/4 inches on the top of Nelson's column if Nelson's column represented all the atmosphere. That is the whole of the CO2, and man's contribution to that is 1 millimetre. So a piece of bird shit on the top of Nelson's column is man's contribution to the content, fraction of content of CO2 in the atmosphere. Now, termites produce 10 times as much CO2 as does man. So if CO2 is a problem, we should have war on termites, which means, it gives Obama something else to do in his last year or two. But you see, it's bonkers to claim that man's CO2 is key when this is going on. In fact, 96% of the CO2 flux in and out of the biosphere is nothing to do with man. So, and I put this to Greenpeace people. I say, oh, well, it's the straw that broke the camel's back, isn't it? Well, okay, but how come the ants didn't break the camel's back then? I mean, it's just a ridiculous argument. Man isn't the last, well, no. The CO2 coming in and out all the time. It's not bits being added and heaped up. It's not even like that anyway. Okay. So just to get these out of the way, as a fact, there's no evidence for CO2 climate driver proposition, because in the real data, temperatures do not follow CO2. In the real data, CO2 follows temperatures. And in their own models, the CO2 has no effect on the jet stream. Because I was at one of those meetings in the Royal Society, and the guys suddenly, because they agree now that the wild jet stream is a main characteristic of the current extremes in climate. but that's what's happening. You've got big changes in the jet stream, wild bends in it, and I got an email recently from a pilot of Iceland Air who said, "You're right, Mr. Corbyn," words to that effect. What we see now as pilots is wild variations in the jet stream. That is what we see as climate change, meaning that, whereas before the jet stream would be just kind of wave around and not to, now we have these great big surges downwards, surges upwards, and so forth, which makes weather forecasting more difficult and can also be disadvantageous to flying, or advantageous if you got it in the right place. I think that isn't going to stay, is it? No, it's not going to stay. There is actually a small leak in it, because I took it to green gathering at the other Friends Meeting House, where it was Naomi Klein going on about, this changes everything. This is climate, you see. And I left it somewhere, and I noticed it had gone down a bit, and then I looked around and I saw a little badge in it. I've got the badge still as evidence, but somebody stuck a badge in it, and there's a little hole, so it's leaking out. And it was called a Earth First badge, by the way, so if you see them, remember. Okay. Sorry. Right, I've explained that point about war on ants, and the fundamental reason why the CO2 theory can never work, even if CO2 is having the effect they claim as a gas, which is arguable, which we could discuss if you want, the amount of CO2 is going to be controlled by the ocean-atmosphere interface. That's just like if you warm some fizzy water, then the CO2 comes out. But if you put CO2 on top of some water, the water doesn't get warmer. So there's a process going on, but what they have is a complete confusion. But the important thing to understand is there's going to be an equilibrium between the liquid, which is 70% of the globe's surface, and the atmosphere. And the CO2s go in and out dynamically all the time, and the equilibrium proportions depend on temperature of the ocean. They might suddenly want to say temperature of the atmosphere, but you see, the ocean is going to rule, because the heat capacity of the ocean is vastly more than the atmosphere. And the CO2 content of the ocean is also 50 times that of the atmosphere. So again, this thing like ocean acidification is utter twaddle, because even if all the atmosphere CO2 went into the sea, it would only increase that CO2 content of the ocean by 2%. Well, and given all the buffering solutions in the sea, the idea that it's going to make it more acid, or in fact less alkaline in any significant way is nonsense. However, the BBC is not interested in science in the proper way. Just a quick one to get these out of the way. This is Al Gore's graph, and you remember he marches around the room and says, time's going this way. So look at it all there we have the CO2, and here we have the temperatures. Is that the right way around? Yeah, that one's CO2, this is temperature. So it's a no-brainer, he says. Well, of course, but if you look closely, one thing that's wrong with this argument, there's a lot more fluctuations in the temperature, because bear in mind this is 150,000 years. There's a lot more fluctuations in temperature which are not shown in the CO2. So how the CO2 can be causing these fluctuations when it's not fluctuating itself is not explained. Furthermore, if you look at details, you see that the changes of the CO2 follow changes in temperatures, and there's a graph that comes up in a minute. The other things which are significant in here is the gaps between these. Quite a lot of them are multiples of 43,000 and 26,000 in various combinations. 43,000 years is the period of the change of obliquity of the Earth, which is this, going like this. The axis goes down and up again in 43,000 years. And the 26,000 years is the precession of the poles, where the pole star is in one place now, but in 26,000 years the pole star won't be where the North Pole points to. So those things are obviously going to be connected with solar activity, or if anything's coming from the sun, which is charged particles, these modulations will affect the amount of impact on the Earth. Because if it's more the pole facing, then it's going to have a bigger magnetic cross-section and so forth. So there's going to be optimum situations which will allow most impact from particles from the sun guided by magnetic connections. Hence, it's not surprising that we do see these figures in ice ages or not, for a start. And the 22-year signal, for example, in world temperatures, which is the magnetic cycle of the sun. The 11-year cycle being the sunspots, and the magnetic cycle being the alternate sunspots, because the direction of the sun's magnetic field changes for odd and even cycles. And this was a graph we'd done years ago, and it's curious. I mean, these graphs are quite, well, some people have done a lot of them, but they rarely find their way into literature. You know, I show this to people, and they say, oh, I haven't seen this before. But, you know, it's not even difficult to do. And we did this years ago. As you see, we did it in 1998 and haven't updated it, but it wouldn't change much. So if you look at geomagnetic activity, which is basically the noise due to the solar wind hitting the upper atmosphere, and it causes wobbles in compass needles. So it's a measure of something to do with the stream of things coming from the sun. You see the main thing is an 11-year signal, okay? But the actual weather, the main signal is twice that period, i.e. the magnetic one. In fact, here it works to a decimal point, basically, although the average is more like 11 years, but it depends on the precise data set you choose. But we chose that one, which is short compared with what's available, but because the geomagnetic activity was more reliably available. Or possibly the temperatures as well, but there we are. But it shows what you want to know. Many other signals in there, none of which are explained by standard meteorology. Now, one of the most significant things is a kind of envelope over temperatures, and this is American data, and if it doesn't happen in America, it doesn't happen anywhere, as we all know. Within these, you can check these, there are 22-year signals, but there's a kind of 60-year envelope, you see. It's it's a kind of, it's like an amplitude thing, actually, you see. High amplitude, low amplitude, and so on. Which is a beat phenomena. It's a standard pattern of a beat phenomena. And this is actually the beats between the 22-year cycle and the frequency at which the lunar nodes rotate. The moon, you see, rotates in a plane relative to the Earth. If this is the plane of the ecliptic, the moon crosses the plane of the ecliptic twice in a rotation, but the position of that moves backwards. So the lunar nodal period, as it's called, the node being where there's no difference between the latitude of it and the ecliptic, the lunar nodal period is 27.212 days. Because it's moving backwards, you see. Now, so what has this beat got to do with the solar wind? Well, as far as we understand it, is that because the moon's moving into a different plane above and below the ecliptic, it's changing the way it's affecting, not necessarily magnetically, but it could, well, magnetically as well, but it's affecting the solar wind just by blowing past it. This is 22 years is the Hale cycle, the magnetic cycle that is, and about 19 years is the full nodal precession rate. So 19 from 28 is 3. So when you've done 3 of these, you've done half of the 19. So you've got instead of being in a plane where it's pointing downwards, it's pointing upwards. So you need 3 times about, well, either 22 or 19, you see, or 3 times 20, and you get about 60. So if you do the calculation properly, which you can, it's not difficult. It's just beats. It's difference between beats. You can see you get out about 59 years. Okay. Now, just to understand a bit more about magnetic connections and the sun and so forth, I don't know if you did this earlier, but you could have done, in that it's important to understand there's a big difference between odd cycles and even cycles in terms of electron and proton flow, because you've got this current sheet around the sun, because the magnetic field is stretched outwards in one and inwards in the other, so there has to be a current sheet there to maintain that pattern, if you like, and they work together. So but because particles have to come outwards, they don't flow inwards, it means particles in one in odd cycles you've got electrons are the average flow. There's a dominance of electrons in what comes out, not necessarily large dominance, but there is a dominance. And in the even cycles it's protons coming outwards, and that must have a bearing on how the solar wind, or in particular those currents, interact with the Earth in the ways you've discussed. And you've probably seen these pictures, which I won't go into, but just to say, look, you know already there's loads of stuff going on up there, and as you've already heard, these are totally connected with what's happening down there. And bear in mind, what is happening down here in this atmosphere, our atmosphere is just a piece of paper this thick on the surface of the globe, right? I mean, you know, this is 4,000 miles in there, and this is 7 miles, the thickness up to where aeroplanes fly. Might be slightly thicker than that here, but you know, it's not a big deal. So the idea that somehow what happens in this sliver is totally self-contained when you've got everything out there happening, and furthermore plenty of stuff underneath, but you know, even leaving that aside, it's just completely insane to say this is self-contained and can be predicted on its own history. It's complete lunacy, and spending another billion on as many computers as you like will never, ever produce long-range forecasts more than 5 days ahead, because the noise level of the atmosphere, when something has happened, it dies away after a few days. Is that noise level, that power, is less than the average power that comes in the solar wind. Now, you could live on a different planet where it might take 100, if you live on Pluto, it might take much longer for, the noise of an event in your surface to die away and become as weaker than an impact from the sun. Okay, but on Earth, this is only a few days, this period, and this is a kind of fundamental limit to standard meteorology, and there's no way of overcoming it. But not talking about what I said is a good way to get money off people who want to give it you, especially if you say man-made climate change is the problems of the world, and you can pay taxes for it. Okay, now, very interesting observations here. I mentioned this 27.212. Okay, that is the lunar nodal period. Well, it is also the period at which a point from the sun goes round, on average, not at the equator, but a bit above or below the equator, goes round and comes back to you. So the lunar nodal period is the same as the rotation rate of the sun or the sun's magnetosphere. The same as. Now that's something's going on there, right? Now there's only one other planet moon pair where this happens, and this is Pluto and Charon, where the ratio is 4.0. All the other moons and their planets have some ratios which are of nothing significant. So I would say there's some type of feedback phenomena which is causing this, involving transfers of angular momentum in the solar wind, ionosphere, and so forth. Okay, and we've got some ideas about that, but they are, well, will be released in due course. But I mean, best to say anything we said would be even more controversial than saying hello. So, you see, this is. I know some people just say, just a coincidence, but, you know, there's just too many coincidences sometimes, especially when they seem to mean something and you can use them to predict. All right, actual facts, actual observational facts. This is time going this way, medieval warm period, which is the one they tried to suppress at the Climate Research Unit of East Anglia. The Spora minimum, these are the colder periods, the Spora cold, the Little Ice Age, the Dickens winters, and so forth, and the modern era. And these correspond to levels of solar activity, i.e. the medieval optimum was more solar activity, as measured in this case in terms of carbon-14, than opposite to the creation of carbon-14, i.e. when there's more magnetic activity, high energy cosmic rays are excluded from the atmosphere, so there's less carbon-14 formed from the nitrogen. Okay, so you measure that and there you are, and you see these correspondences. I.e. on average, it doesn't mean every year, but it's got to be over hail cycles, numbers of hail cycles. More solar activity is a warmer world. Now, crucial thing for, and this is our contribution, if you like, to things, is the question, what causes weather extremes and climate change? Right, and our answer is the jet stream. Now, the standard meteorologists, which I started talking about earlier and got lost, at a meeting in the Royal Society, they said, we don't know why, but when we change the CO2 in the atmosphere, it doesn't affect the jet stream. And I stood up and said, well, I know why it doesn't affect the jet stream. It's because it doesn't affect the jet stream. And furthermore, I can tell you that it's the sun that's affecting the jet stream, and we predicted these wild variations would happen now, and they will carry on happening for the next 20 years because we are in a mini ice age period, or that's a way of describing wild jet stream behaviour. So, next question is, well, what moves the jet stream? And this is our answer. Solar particle magnetic activity and lunar modulation. So hence we have our solar lunar action technique. And they're largely predictable, whereas a CO2 can predict nothing. And also, I would add, the cosmic ray theory itself, by itself, can predict nothing. I'm not saying cosmic rays are important, yes, but the actual energy coming from cosmic rays is 1/300th of the energy coming in terms of particles from the sun. Even though they're higher energy individually, but you see the particles themselves, these high energy cosmic rays, have got a very low cross section with any collision. They have to collide with many things to form pions and all that stuff, and then those interact. So if you remember cloud chamber, which seems to be reinvented every so often, but when we did cloud chamber physics in Physics 1, Imperial College, you remember, Philip, don't you? That those tracks of particles, the slowest ones gave the biggest tracks. It wasn't the fast ones, it was the slow ones, because they're slowing down and catching stuff, you see. So high energy things have to hit something and break up into lower energy before they have big impacts. So the low energy stuff from the sun, that's why it is important as well. And the reasons you've heard from earlier, of course, there's a whole system of connection between all levels of the atmosphere down to the ground. So obviously, you know, the sun then is going to rule. And the cosmic rays are not irrelevant, but they're much more important for understanding things to do with stellar formation and so forth, you know, on a much bigger scale. Okay, so our long-range forecast using this, but I haven't given you any details. They can be done, they are being done up to 12 months ahead. They're very good at extremes, over 80% accurate over a few days, and we've got detailed forecasts for the USA, Europe, Britain and Ireland. And we've had very big success in long-term, long-range tropical storm forecasts, but we haven't done it consistently. The most significant things to look at are the R5 and R4 periods. That's when there's more activity, more hits, more particles from the sun, and also you do statistically, it appears to be that when you've got these big events on the sun, you get your R5 and R4 happening. You also tend to get more big earthquakes and volcanoes. But you mustn't get confused with the, aftershocks and so forth, which make a difficult problem in analysing. But anyway, and if you want to buy them, they don't cost you much at all. Okay, now, so the basic idea then, all right, so is that world temperature or any parameter is going to be governed by solar activity, modulated by magnetic links. So you've got 11-year and 22 years, which will come out as a 22-year, obviously. And you've got a lunar modulation. That's the simplest thing. Now, there's also going to be a stratospheric wind thing, because in the layers above the upper part of this, there's stratospheric winds going east to west, and they flip around with a period of 2 1/3 years. Now, it's kind of obvious that is going to be a modulation. So you're going to have a whole set of problems to do with stratospheric winds. And we have a very interesting finding recently. We said, well, okay, you can get a solar activity and a lunar bit right, but then the stratospheric, because you want to look in the past for when we had a similar linkage as to sometime in the future as in the past. So you could go back multiples of 22 and go back multiples of 18.6, and you're going to get somewhere, but it's never going to be quite right. And then you've got to think about timings of what we call these red spikes, or these R5 and R4 periods, and whether or not the stratospheric winds are right. What we find is that the stratospheric wind issue matters most when we have an R5 and an R4 period. And then when we don't have those, it doesn't matter so much. So we have actually two numbers of sets of look-backs in the past. The idea is, okay, you've got your Sun-Earth magnetic weather state describing this whole interaction. It's not a calculable thing in a computable sense. So you've got the future there. We want to describe... No, this goes this way for you, doesn't it? Future there, and we've got your Sun-Earth magnetic weather state. You're going to have some vector of, 1 million parameters, but actually for us it's about 6, okay? And then one in the back past, we said, we're going to find one that's similar, and then we're going to use that weather to describe this. But actually, there's going to be different sets of them in the past which are similar. Some which are best for stratospheric winds, and some which are not, which are best for not stratospheric winds. And the best for stratospheric winds have to be the ones when the R5s and R4s are on. And we made some forecast changes recently in the middle of April. We changed something from dry to wet using this. And we were right. The change from dry to wet worked using a different set of lookbacks. So then, of course, you've got a problem. You've got some parameters going blah, 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 and then this other bit comes in and is different. So it's a join-up problem. But funnily enough, it's sort of, you can see it, it could work. You know what I mean? The join-up problems are not as difficult as you might think. It's as if, things are just helping us. Does that make sense? Okay. We'll just get past these because we've already talked about the stratosphere and so forth. I predicted some snow, and there it was. And that's the Daily Express, and the photo was taken by my son, who was 12 at the time. But he didn't want to make the snowman. He made me make the snowman. Which I thought was... Throwing snowballs okay, but making a snowman, no, Dad, no. Anyway, right. 132 years. 6 times 22 is 132. 7 times 19... or 18.6 or whatever you want to choose exactly, 133. So 132 or 133 years ago, things would, in general terms, be similar. Okay? Now, I was at some centenary dinner in Imperial College, Philip. I was invited to the President's Centenary talking, whatever. So I went there and I said, guys, there's been loads of floods in this is 2007, you see, floods in Trent Bridge and all that. And I've got a friend who does meteorology and cricket, and he goes to Trent Bridge and he says, Piers, I've got all the dates of when the floods were, because they're all marked on the bridge, you see. And he just phoned me this. What, really? So I said, well, look, Because there were floods in 2007. We just had some at that president's dinner, and 1875, 132 years. You see, I said, well, if this is true, then we're going to see some more, because there were some in 1876 and 1877. So we see. Now that happened. There was floods, 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 and then 2010, a kind of test of not floods. There was not floods, and there was not floods in 1878, and then 2011, 1879 was the kind of just in the north, and this one, 2012 and 1880, was absolutely astounding. In southern England, they were near record amounts of rainfall in both data sets. You know, near the top of all these years. So, you know, someone who says it's CO2 is talking nonsense. The various things like the Russian superheat wave and so on, these things do also follow these type of patterns. But be careful, they're not clockwork. You can't just take a date and a date, or even a month and a month. But, you know, there's going to be confusions about stratospheric winds that I just mentioned, for example. But the general picture does work. And you might recall that the Met Office predicted these summers as barbecue summers. There was their first barbecue summer, and their second barbecue summer, and their third barbecue summer. and anyway, enough said. The 60-year cycle is all pervading. This is a one of Atlantic multi-decadal oscillation. Okay. Well, there's lots of these measurements in standard meteorology, which when they find another one, they sort of say, oh, that's it. And they attribute cause to something they've just found, but it's of course nonsense. They're all description. It's a bit like seeing a hill and a valley. You say, look, that valley has caused that hill. I mean, it's stupid. They're just things. They're description. We've got them right now saying the heat in the Pacific is causing these cold plunges in America. Mm-hmm. Well, why not the cold plunges in America are causing the heat in the Pacific? I mean, why not? They're just descriptions of something caused by external things. Mississippi big floods also happen. Super floods happen in approximate 60-year cycles. There's the formula. There you are. Those of you like formulas. Philip, remember formulae. Ta-da. He just... It's just a beat thing anyway, so you know, you stick these, whatever these ends are, that's the beat. So anyway, you get out 59, 58 years, but it depends precisely on the magnetic cycle of the sun. Period. Right, and if you look in the detail, this is quite interesting. When do you get warm periods? The answer is you get a warm period when it's got to be one odd or even sunspot cycle, and the answer is it's got to be odd sunspot cycle maximum. These are the odd sunspot cycles. There's a maximum starting there, and then it's falling, and then after that it's rising again. So you're only putting that, which is a quarter of all the post pictures. And if you also have eclipses of the sun in the first 2 weeks of December, in or near those years, then you get your heat. Okay? So you put in where you've got eclipses of the sun in the first half of December. Now you might say, well, what's that got to do with anything? But yeah, it's just a way of timing it. You could choose anything, but I did choose that for some reason, which I think it's because the Earth is actually crossing the plane of the solar equator at that time, but it doesn't matter. You see, you could use anything. But there you are. You see, close together. Solar cycle 23, not so close together. Not so close. Solar cycle 17, close together. You see, higher, and then go back again. Blah blah blah. Bit of confusion and mixture. But number 11. There we are. So you get these are going to be roughly 60 years. Just a list of some of these things achieved. This 2012 was a very major extremes, you remember. Basically, it was the year of no summer. And of course, it's a bit... there was another year of no summer in 1816. Now, by a curious coincidence, there was a big reduction in Arctic sea ice in 2012. maybe a temporary one, but it caused the global warmers to jump up and down, proving man-made climate change. However, there was another one in 1816, coinciding with the last, reasonably argued for, year of no summer. So these bits of ice or whatever disappearing in the Arctic are not actually controlled by the atmosphere anyway. They're controlled by big circulation questions, which also involve sea circulation. So, the point is these wild fluctuations are not in any way evidence of CO2 doing anything. This is my favourite storm because we predicted this a long time ahead. We announced it in I've still got the pen from it, Hotel Kempinski, which is a very flash hotel by Lake Geneva, where I was there for the international commodity trader operations. Anyway, I said then, 6 months ahead, we're going to have a big storm, late October in southern England. And here it is, you see. It came on cue. There's a bit more about it. There were simultaneous things in America, which we'd also predicted, but not that long ahead. But we could have predicted them longer ahead now. We also made some rather specific claims. We had a map. There we are. We said it's going to go something like that, and here we have it. You see? That was a map. That was probably drawn a few weeks ahead, but it was derived from what we'd said months ahead. So we had corresponding maps. We did say it would be on a par with the Great Storm of '87, but it didn't mean the same everywhere. And in fact, the winds in Holland were bigger than anything that happened in 1987. So as a storm as a whole, it was comparable. For England, it wasn't. We also make these interesting little predictions about the changes of storm directions, and we started doing this for tropical storms, making statements that, okay, you've got your tropical storm, it's going to be a standard model saying where it's going to go, and we say, well, it's either going to go to the right or to the left of that. Or it might be pretty well on course, in which case we'd nothing to say. But we did say this one, and this was happening due to there was going to be an extra R5 hit as it was approaching Britain. We said, it's going to veer to the right. And it did. This was our, I don't know which is the prediction, but there we are. That's what happened, and this was their prediction, you see. So it did veer to the right. I mean, not a big deal, but it's significant that we had something to say. And then there was another one, 2014, which wasn't such a big storm in the south, but it was quite a sizable thing in Scotland. And that was also, they're not always going to be flips to the right. This Gonzalo caper, it did go to the right anyway. And it was an R4 period. So the idea that, well, you can read, can't you? That recent man-made weather extremes around the world are driven by man-made global warming is delusional nonsense. And I said this to the Met Office long-range forecasters and indeed called them charlatans, which they didn't like, but I suppose one wouldn't. But on the other hand, they pretend that they're forecasting when they're not. So, I mean, that's what doctors do, isn't it? A charlatan doctor pretends he's diagnosing you when he's not. So it is a correct use of the word, I would say. But it's not to say they don't do good science in terms of numerical prediction. Of course they do, and I've said that. They do fantastic work in terms of numerical prediction, but it's got a limit. Here's quite a one which the warmers like to talk about. Every time they see a big typhoon or hurricane, they say that's man-made climate change. Now, actually, there are less hurricanes now than in previous decades. Less hurricanes and also less tornadoes. But there are some very extreme ones now as well, some of which are comparable or more extreme than some in the past. But this is fully understandable in terms of our theory, and it's also fully understandable on average is going to be less because there's less solar activity impacting. But some of the solar activity that does impact is very extreme and associated with these wild jet stream things, which bring you more difficulties. So they go on about this Yolanda or Haiyan. It's Haiyan for the west and Yolanda, it was the local name. Now, they complained that it hit and destroyed and it was CO2. Must be, they said. Well, funnily enough, when it hit, you see here, it was tropical storm, whoomph, up to Typhoon 5. Just in the period from, sorry, the 4th of November, American description. But the point is, we've shaded in our R5 period, and that is when it comes from tropical storm to super typhoon. And it happened to be when it was just getting close to these parts of the Philippines. So it was like a perfect hit in terms of trouble, but it was solar driven, and this is it. There's the yellow shading, this is our red region, and that's what happened. And it was nothing to do with CO2. Had the timing been different for these red spikes, then it would have just been another typhoon and just killed, you know, a few hundred instead of many thousands. Now, we've written some of these things to New York Times and so on and warn them of blizzards, and they just ignore us completely, let the blizzard happen, and then announce it's CO2 that did it. So they're more interested in people suffering and dying than knowing the truth. That is a fact. Just to show some of the things we did, this is more of these, but we made quite specific predictions about regions of the US of A, of where there would be a lot of stuff, and there they are. But the point was the timing and extremes of these in an approximate area were good in that case. Then we got just a little bit about the delayed spring of 2013 in Britain, which was also happened in America, but they don't always happen together, and there's ice creeping into people's houses from lakes and so on, which is quite, well, horrible, isn't it? Now, I like this one, yes. The Westbury White Horse in April 2013. Now, this looks like February. And, of course, John Constable's drawings of these grim, angry skies, of course, are very similar. John Constable's drawings were done during the previous minimum of solar activity, the Dalton minimum. And just for amusement, John Constable sold most of his pictures to France, to the enemy, who presumably liked them because they showed Britain as being a dour, glum place and nothing like this exciting France, which they wanted to rule the world. But why they wanted to conquer us at the same time, I've no idea, given that it was obviously such a glum place to be. But anyway, this is what happened. And I really like Constable's drawings and paintings because they're so expressive of the weather of the time. And this is what is happening now. I don't know if you've ever seen them, but they're actually quite small. When you see them, you think, wow, it must be big. But they're actually quite small pictures. They're just very well done. He probably couldn't afford the paint, so he did it small. Right, the mini ice age is upon us, meaning that temperatures have declined, will continue to decline under honest measurements. We'll come to some honest measurements in a minute, but here you see the satellite measurements, which are more reliable than surface measurements. This was March 2013, where this is a Met Office diagram. They said for some unknown reason the jet stream was way south, which made it very cold. That's the normal sort of jet stream, and they do it symbolically there, which we'd warned of this very cold spring. And I won the British asparagus competition to predict when the first field-grown asparagus would be ready for market. And I said it was going to be about a month late. And I was right. I mean, it was even 6 weeks, and I was right. I was closest, anyway. We've had a lot of extreme weather since 2010, and they are explicable and predictable in terms of the solar-lunar action technique. And the advent of very extreme events will continue and these jet stream shifts will continue. And the world will continue to cool until 2035. And the idea that CO2 is nonsense. There's been some major economic things, and I'm hoping we're going to get to this video soon. I'm not. We mentioned these are specific things we did warn of. Super cold UK, December 2010. You remember? Very cold USA winter. This tropical cyclone Yazi. These series of tornadoes and Hurricane Irene we'll just have a quick look at some of these because they were quite exciting. We're going to have a look at there just briefly, the jet stream, August the 15th, 2010. And I'm hoping we're going to play a video. But this is a record or like day-ahead forecast. And what's happening here is the jet stream is rushing into Leningrad, or St. Petersburg, as it's now called. And there had been this great, very warm air just down there coming up into Russia. And you'd had this West Russian heat wave. And we said it was going to end around the 15th of August, give or take a day or so, because there was going to be a big event on the sun which would excite the jet stream, change the whole jet stream pattern, and there would be thunderstorms and it would get a lot colder. Well, this is what happened. There we are. Now, we're going to try and have a look at this video. It shows a double-centered sunspot, massive expulsion of material, a coronal mass ejection, and only about a quarter of an hour later, a big impact on the ionosphere, which meant that some influence was travelling at half the speed of light. It doesn't mean all the particles were, but something, some wave or whatever. And the jet stream did indeed move. There we have St. Petersburg, and there were some plane crashes as well due to some extreme turbulence. And we had changes in circulation down in Pakistan, which caused the big floods there to subside, or the rain which caused them to subside. Okay, so we're very pleased with that. And that was August, as we said, 2010. Now, another very exciting was December 2010, where we said, and this is our forecast, probably the coldest December for 100 years. And when I'd written that, I thought, did I actually write that? And I said, yeah, okay, we've written it, let's put it out and see what happens. Well, it was the coldest December for 100 years, and David Cameron said so. So it must be true. Okay. But a funny little story. We're really pleased with that, you know. And then in the middle of it, the height of it, I was phoned up by BBC Breakfast. Said, Mr. Corbyn, would you like to come and sit on our couch in the morning and blah, blah, blah about the weather? I said, yeah, of course. Great. Okay. We'll arrange a car. Okay. Okay, thanks. So you'll get a call about the car in an hour or so. Now, I was with a friend of mine, the late Andy Wilson, I have to say. It's very sad. He was from Imperial College as well. Anyway, I was with him and I said, Andy, that call hasn't come. I better ring her back. So you have to go outside there. You can't make phone calls in this place, you see. It's a very strange place. So I made a call and, this person, Mr. Corbyn, yeah, sorry, we meant to get back to you. We've got someone else. I said, oh, please, tell me, who have you got instead of me? Because after we did forecast this, you know. That's why you wanted us, wasn't it? She said, yes, well, we've got someone else. I said, who? And she didn't want to say. I said, well, come on, you can just tell me who. She said, it's the government's chief scientific advisor. And I said, well, he knows FA. Now, I used the Queen's English version of FA, i.e. the full version of FA, which I don't think she appreciated. But anyway, that's what I did, and they didn't phone me back. So there we are. But, you know, that's what happened. We've had a number of these calls from researchers since, and often I've said to them, well, yeah, it's great, I'll come, but I think your boss is going to say no. And then they come back and say, blah, 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 and they go waffle about some timing problem and not appropriate for the time of day and, well, you know. But they never say the boss, Ted, no. But I think it is usually the boss says. Anyway, the point is the BBC have made a conscious decision. They want to propagate the theory of man-made climate change and nothing else. Specifics, which we mentioned before, 2011, we used the phrase tornado storm. We listed affected states, Missouri. Joplin, Missouri was destroyed in that time window. Now this one is very, very important just to know politically what happened. We predicted from 85 days ahead there would be a storm in 2011 in August which was going to start or be identified somewhere near Bahamas or somewhere down there and skirt around the USA, go near the edge and making some close hits or something, right? And it happened. Exactly that happened. And they had their storm track of what they then called Hurricane Irene. And they kept on warning, oh, it's going to hit, it's going to hit. Evacuate, evacuate. And I was in touch with NOAA. I phoned them up. I said, look, okay, guys, that's nice. But look, just want you to know what we're saying. It ain't going to hit. Not in a big way. It's going to veer slightly to the right, and then it's going to start, after a while, run down. But our 4-day ahead, as to the detail, was better than their 1 day ahead, right? And I got some people in there who were quite excited. Said, hey, that's great, that's great. We'll be in touch, we'll be in touch. Afterwards, it was complete silence, as if I didn't exist. I mean, you know, you would think if they want to improve hurricane forecasts, they might ask someone who had done a hurricane forecast that was better than this. I mean, you know, if someone did a weather forecast that's better than mine, I'd ask him, did you do that? That's what I would say. Sorry, I wouldn't swear. No. But you understand. I mean, it is ridiculous. However, there's politics at play here. Okay, 2012, my favourite picture of all. Is anybody here from Newcastle? No, good, okay. That's Newcastle being hit by, is the bridge, and these hailstones, which are big by British standards, but small by American standards. A common phenomena in these mini ice age wild jet stream circulation patterns is extreme hail events. And this is destruction of vineyards, which will happen more and more. So those, if anyone here is thinking of growing a vineyard because of climate change, I must warn you, this is your likely fate. So get insurance and find it from a believer in man-made climate change, and then you might make a profit out of it. July 2012. Yeah, this was in America. We said there's going to be all these extremes, and what's up with that blog said they would put our forecast to the test. I said, okay, do it. And they said, look, you're just being completely over the top. It can't be like that. Well, actually, it was like that. And we had these hailstorms often when we predicted. And then these guys started arguing the toss. Well, it wasn't giant hail, it was only big. Or it wasn't big, it was giant. I mean, look, please, come on. Have you had hail, have you not? Well, yes, but it was the wrong size. So, you know, they were trying to pick these minute holes in the forecast. But after 2 weeks, they said, oh, we're going to end the assessment now. So we only had 2 weeks of them getting increasingly upset. This was just to show when we give these time windows, this was the R period, and how there's different geomagnetic measuring stations around the world, and it's often more interesting to look at all of them instead of the kind of conglomerated average. And you see, this is our time window, and here were these events in that time window. The ones outside, there's just one there and one here. So that one's probably part of something else anyway. So really the identification of these events is good. And the extremes, well, again, the extremes were there, but actually these were shifted a bit. So we got to find out if SLAT 12 would have got those in the right places, but they were there around somewhere. We know it's not CO2 because the data shows that CO2 theory does not work. Now, and that's just a few graphs to show you, as you know, it doesn't work. The IPCC temperature forecast scenario was this, and what actually happened in this period, using the same data as they were using there, was it went down. The CO2 went up, yes, but the temperatures went down. Or then they readjusted the temperatures and said, oh no, they didn't go down, they stayed flat. Well, okay, they can, fiddle what data they want, but they certainly didn't go up. Now, key things to understand. What they said under their models in 2000 was world runaway warming and the world has got colder and CO2 has gone up. Or their new fudge data stayed the same. Droughts and heats, UK, not at all. We had floods, cold and hail. End of snow, nope, not the end of snow. More USA hurricanes, there's actually been less USA hurricanes. World massive ice melts, there's been more world ice. The BBC lies regularly about ice. Or, no, let's say they speak the truth, but only half the truth. The truth which they want to speak. So when it melts, they tell you, but when it reforms, they don't. It's a bit like the bank rate. Harold Wilson was always reported as lowering the bank rate, but they didn't put on TV when he put it up, you see. He lowered it 20 times, I believe, in his office. 20 times. Isn't that fantastic? Early springs, they said, no, we've had late springs. Large sea level rise, no. There's been no change in the rate of sea level rise since in the last hundreds of years. This is the same things done geographically, which was, well, you know. And they say the science is settled. All right. These are just amusing. You might like this one. I became an Al Gore climate reality presenter. You mean you joined a religious cult? What? Climate change is a religious cult. You believe in things you can't see or prove. You attack and ridicule all evidence to the contrary. You sell carbon credits as a means for sinners to repent. You warn of horrible punishment for not believing, and you constantly try to convert non-believers while your leader gets rich from your unpaid labour. Misspelt, I notice. That is a cult. Well, it is a cult, isn't it? And Al Gore is on top of it. There's the graphs about the hurricanes, and there's a graph about tornadoes, and this sea level graph is quite illustrative, you see, because sea level rise is going to carry on if this is the surface of the sea, and there's the bottom down there. Heat is still going downwards, and it's expanding the lower bit slowly, and that's going to carry on because the sea is very down there. It's still cold compared with what it was. So heat is seeping down slowly, and there's also stuff coming off the seabed. But leaving that aside, so it is warming up slowly and expanding slowly. The rate of expansion has stayed constant. If it was CO2 driven, it would have shown a big step up like that since the 1920s or 30s or 40s. But it didn't. Under their model, that shouldn't be there. It should go up here. It doesn't. So they fudge the data on that. They just say, look, sea level's rising, but this means nothing. Now, they have these different data sets where, yes, Minister, they are proper data, Minister. But what they've done, they just choose data, and they've reduced the amount of data since before 1990, but they've reduced it by 2/3. So what they do, they had this data set they described as the data set to rely on in 2001, which was the black one. And you see the black one is there, you see it goes up to there. And they've successively modified different data sets and claimed they're the same to make it colder in the past and warmer in present. So the rise from there to here is that now in this one is that, and that in the older one it was that. So they've got an extra 0.5 degree warming has been incorporated purely by choosing data. In other words, it's fraud. And it means that the warming now is actually no different from the warming that happened in the 40s. No different. So we haven't had any warming at all. That's about removal of data sets. This is numbers of data points, and this is temperatures. So take away the data they decide to take away. There's more of the same sort of stuff. That's just to show you that temperatures go up, this is time this way, later CO2 goes up. Is using ice core data. The lag of 800 years might be 500. Stuff about sea ice, you can see that at your leisure, where they publish one thing, not the other. Their weak link, if you like, their whole theory is CO2 causes global warming, that causes climate change. They stopped talking about global warming because there isn't any, so then they've got somehow a magic jump from CO2 to climate change without the warming in between, which is nonsense again. It's a chain without a link. This is our view of what actually happens. Solar activity drives loads of things way up there, here. Then that changes the jet stream, that causes circulation patterns, which in the end causes CO2 levels. CO2 is the gas of life, not death. We do not have CO2 causing this, and that is not causing the jet stream, and that is not causing the magnetic field thing, and that you driving your car does not cause a solar flare. It's the other way around. Well, no, you see what I mean? And I'll end, this is almost the end. Temperatures. This is solar activity as measured by various modes with a gap, and then solar activity again, but 221 years later. Now, they do correspond, and we know about the 22-year period, so as long as they're smoothed over 22-year periods, this is going to be a reasonable approximation to world temperatures. Now, we are here. We're at the knee, so that's where we're going to go. down and down and down until, 2035. Right about, so coldest will be 2030, 2035, something like that. Most important graph to remember, that one. This is the answer, what you've got to do. You've got to enjoy life and enjoy the planet, and accept that man cannot change climate, and you've got to stop carbon reduction. You should make more carbon. It's good. It makes plants grow. End the prayer wheels of wind farms. Have money back on green electricity charges. Actually, there is a party which is more or less saying this, namely UKIP. I'm not saying that I agree with UKIP on other things, but they are the only one that's got an intelligent policy on energy supply. We should keep honest green policies as well, though, i.e. don't throw the baby out with the bathwater. So, but defend biodiversity, because biodiversity is a good thing. You don't have to latch it onto something which is false. And of course, you could even use scientific long-range forecasts to improve the world. So I think I will end there and just say enjoy life, and I'll enjoy some questions. Thank you.